In this video, I'm going to discuss about binomial distribution. A random variable follows a binomial distribution if the following four conditions are met. First one is there are a fixed number of trials or observations which is represented by a small letter n. For example, a group of 50 students, or a sample of 100 customers, or tossing a coin repeatedly for 10 times. The second condition is each observation has exactly two possible outcomes, either success or failure. For example, a student whether wearing glasses or not wearing glasses. Or when tossing a die repeatedly, even though we might get number 1 or 2 or 3 up to number 6 when tossing a die, but if we are only interested on obtaining a 6, then obtaining a 6 is considered as success, and not obtaining a 6 is considered as failure. The third condition is the probability of success of each observation is the same. For example, when tossing a die repeatedly, if we are only interested on obtaining a 6, then the probability of obtaining a 6 is always the same, which is 1 over 6. The condition number 4, that is, the observations are independent, which is the first outcome will not influence the following outcome. Now let us try to determine whether the following situations are suitable to be modeled as binomial distribution. For the first situation, 10% of people in a town having blood of type B. A survey asking 100 people about their blood type. The number of people with type B blood is recorded. For this situation, we found that there is a fixed number of observations, which is 100 people. Each people is either type B blood or not type B blood. The probability of obtaining the people with type B blood is always the same, which is 0.1. And finally, the outcome will not influence each other. Therefore, this situation is suitable to be modeled as binomial. Number 2. Counting the average number of MyV cars in a car park. For this situation, since we do not know how many MyV cars are in the car park, so the number of observation is not a fixed number, and the outcome may be 1, maybe 2, or 3, or 4, so the possible outcome is more than 2. Therefore, this situation is not suitable to be modeled as binomial. Situation number 3. 3 marbles are drawn without replacement from a bag containing 10 black and 20 white marbles, and the number of black marbles drawn are recorded. For this situation, there is a fixed number of observation, which is 3. There are 2 possible outcomes, which is either a black marble or not a black marble. However, the probability of obtaining a black marble is not the same every time, because the marbles are drawn without replacement. The marble drawn on the first will affect the probability of later marbles. So therefore, it is not suitable to be modeled as binomial. Now we proceed to the next situation where a face 6-sided die is rolled 10 times and the number of the face is recorded. For this situation, there are fixed number of trials, which is 10 rows. Each row is independent of the others. The probability of obtaining each number is the same, but there are 6 possible outcomes, which is 1, 2, 3, or 4, or 5, or 6. So therefore, it is not suitable to be modeled as binomial. However, if we change this situation becomes a face 6-sided die is rolled 10 times and the number of 6 is recorded. For this situation, there are fixed number of trials, which is 10 rows. Each row is independent of the others. The probability of obtaining a 6 is the same, which is 1/6 for each time of rolling. And there are only 2 possible outcomes. Either it is a 6 or it is not a 6. So therefore, it is suitable to be modeled as binomial. If x is a discrete random variable follows binomial distribution, then x can be defined as the number of observations. Because x is a countable, so we use the number of. Then followed by the observations which satisfy the success criteria that has been specified out of the n observations. For example, in this situation, 10% of people in a town having blood of type B. A survey asking 10 people the type of blood. The number of people with type B blood is recorded. In this situation, x can be defined as the number of people where the observation is people, and the success criteria is the people who have type B blood will be considered as success. And finally, this number of people is part of the 10 people in the sample. The second example, a face 6-sided die is rolled 10 times and the number of 6 is recorded. In this case, x can be defined as the number of rows. We have only one die which is rolled 10 times. The success criteria is obtaining a 6. This number of rows are part of the 10 rows. If a discrete random variable x follows a binomial distribution, then the probability distribution is denoted as this way, where B stands for binomial, N is the number of observations, and P is the probability of success of each observation. The probability of the value of x is this. And for binomial, x will take on a finite number of observations up to n. The mean of binomial distribution is NP and the variance is NPQ, where Q is equal to 1 minus P. Now let us look at this question. At a supermarket, 65% of the customers pay by credit card. In a survey, a random sample of 20 customers is selected. State the probability distribution for the number of customers who pay by credit card. For this question, X can be defined as the number of customers with the success criteria where who pay by credit card out of 20 customers. Since this question satisfies the conditions of binomial distribution, so the probability distribution of X is a binomial distribution with the parameter n is 20 and the probability of success for each customer is 0.65. The next example, in a large population, 30% of the population is left-handed. A sample of 6 people are randomly chosen from the population. The question A, calculate the probability that more than 2 people in the sample are left-handed. In this question, we need to calculate the probability of more than 2 people, which means that we need a probability distribution for a random variable. Since we need to find the probability of more than 2 people, so the random variable X can be defined as the number of people. And the success criteria is the people who are left-handed. And this people is part of the 6 people in the sample. Therefore, X follows a binomial distribution where n is equal to 6 and the probability of success is the probability of the people left-handed, which is 0.3. In question A, we are going to calculate the probability more than 2 people, which is denoted as P, stands for probability X greater than 2. Since X is a discrete random variable and n is equal to 6, so probability X greater than 2 is equal to probability when X equal to 3 plus probability X equals 4 plus probability X equals 5 and plus probability X equals 6. The probability of each value must be calculated separately by using binomial formula. The alternative way, probability X greater than 2 can also be calculated by using 1 minus the probability X equals 0 minus the probability X equals 1 and minus probability X equals 2. If the list is too long, we can also use the summation notation where the lower limit of X is 3 up to the upper limit of X until 6. Using the button of the summation from the calculator, then we got the answer as 0.2557. We continue to the second part of this question. 3 such samples of 6 people are taken. Find the probability that each of the 3 samples has more than 2 people who are left-handed. In this question, we are going to find the probability that each of the 3 samples. Now, the sample is the observation, which is different from the variable X, where the observation is people. So, we should create another variable by using different letter. Say, we use letter Y. And each of the 3 samples means the number of samples. Then, what kind of samples are considered as success? That is, the sample consists of more than 2 people who are left-handed are considered as success. And this number of samples come from the 3 samples taken. So, Y is defined as the number of samples with more than 2 people who are left-handed out of 3 samples. Since Y satisfies the conditions of binomial, then Y follows the binomial distribution with n is 3 and probability of each sample to have more than 2 people who are left-handed is 0.2557, which is taken from the answer in question A. Now we are going to find the probability of each of the 3 samples, means probability of Y equals 3, and by substituting the values in the binomial formula, then we got the answer as 0.0167. This question can be calculated using another method. Since we are going to find the probability that all the 3 samples have more than 2 people who are left-handed, this means that the first sample has more than 2 people who are left-handed, and the second sample also has more than 2 people who are left-handed, and then the third sample also has more than 2 people who are left-handed. The probability of the sample which has more than 2 people who are left-handed can be taken from the question A. When calculated, the answer is 0.0167. Question C. Find the probability that one of the 3 samples has exactly 1 person who is left-handed, while the remaining 2 samples have more than 2 people who are left-handed. Since the question is finding the probability that one of the 3 samples, and we do not know which sample, then we randomly select one by using 3C1. And this sample has 1 person who is left-handed, and the remaining 2 samples have more than 2 people who are left-handed, which means that the second sample has more than 2 people who are left-handed, and the third sample also has more than 2 people who are left-handed. The probability when x equals 1 can be calculated by using the binomial formula, and the probability when x greater than 2 can be taken from the question 1. After calculated, the answer is 0.0593. Question D. Find the probability that one of the 3 samples has exactly 1 person who is left-handed, another has exactly 2 people who are left-handed, and the remaining sample has more than 2 people who are left-handed. The probability that one of the 3 samples has exactly 1 people who is left-handed is 3C1 times the probability when x is equal to 1. Then another sample, but we do not know which sample, then we use 2C1 where this sample has exactly 2 people who are left-handed. Then the third sample has more than 2 people who are left-handed. The probability of x equals 1 and x equals 2 can be calculated by using the binomial formula, and the probability of x greater than 2 can be taken from question A. After calculate, the answer is 0.150. Question E. Find the probability that there are a total of 4 people who are left-handed from the 3 samples. The total of 4 people can be defined as the number of people, where the observation is people. The success criteria is the people who are left-handed. This number of people come from the 3 samples. Since the observations in this question is people, so we are going to change the 3 samples becomes 18 people, which is the total observation. Since this binomial variable has different parameter compared to x and y, so we need to use other letter to represent this variable. Say we use the letter W. Students are reminded not to use letter Z because the letter Z is special reserved to represent the standard normal variable. So W follows binomial distribution with n is 18 and the probability of obtaining people who are left-handed is 0.3. The probability that the total of 4 people means the probability when W is equal to 4. Using the binomial formula, we got the answer 0.168.